Morning, everyone, and welcome to our first session of day 2 of the ESSA convention. I'm going to kick off by just introducing myself. I am National Portreg, Head of Funds at Work and Distribution at Momentum Corporate, one of the chairs for today. I'm joined also by Lindsay Shooters, who is co-chair for today. Lindsay is been in digital media and is a distinguished business journalist, editor, and storyteller in South Africa. He also currently serves as a business journalist at Daily Maverick. Over to you, Lindsay.
Good morning, everybody. I'm just going to assume that this side of the room is quite full because I can't see anybody here. But thank you for making it to an 8 a.m. kickoff.
The lights are blinding here.
The lights are quite blinding, but it's all good. I like the spotlight sometimes. This morning is the convergence of machine learning operations and actuarial control by Stefan Marais and Neil Pretorius. We're going to explore the intersection of actuarial control cycle and machine learning operations. I care a lot about this. I've been covering technology for like 20 years, and I feel that this is a great opportunity for actuaries to kind of scale your skills across multiple, you just make more of yourself. And so I'm quite interested in getting this going. So please, can we welcome our presenters?
Good morning, everyone. I know my voice sounds like I've been gurgling on some nails this morning, but it's mostly not true. I'm really tempted. Maybe I should do the line. I think it was a once in a lifetime opportunity, but so let's go for it. I am Batman. You know. Okay, great. Now you're awake. Welcome to our session, guys. So we are very pleased to have you here. It's been an interesting journey. So this work is a paper that Neil and I wrote. It's our thoughts and reflections on experiencing both fields, the actuarial field and the machine learning machine learning environment. Building practical machine learning models is very different to actually just doing them offline, doing them on your laptop, getting a real predictive model going. Deploying them actually useful in production is something else. Okay, that's what machine learning operations is about. So, cool. So the ACC, the actuarial control cycle, when it was first introduced to the actuarial profession, it was done officially, I think, in the syllabus. Was by at the time Jeremy Goffert was the president of the IFOA. He wrote this at the time of introducing it. In a world of transition for all our disciplines, actuaries can keep ahead of the challenges first by getting our thinking right. So I think this is quite profound. At the time, 2003, like the turn of the millennium, it was clearly the time of everything is being digitalized, everything is changing. Tools are introduced like Excel, these sort of things, and he wrote this, we should keep ahead by first getting our thinking right. So let's see if we can get our thinking right now in a time of changing again. So the question we want to ask is, our modeling is changing, our modeling is adapting, is enhancing. Should our frameworks also be enhanced or changing? So just to summarize what our findings. So we're quickly going to cover everything, and then we're going to take you through a journey of how we got there, and then Neil's going to summarize this again at the end, and hopefully it'll make more sense. But we know that machine learning is augmenting traditional actuarial models. This is obvious. I think most of you have seen papers published. Machine learning is getting more and more introduced in our syllabus. But what we know from machine learning operations and actually the machine learning engineering field is that it's really difficult to actually integrate a machine learning model in operations. And what I mean by that is it's in production, it's integrated in the business environment, or it's automated. So getting that integrated, we know from not from the actuarial experience, but from the machine learning engineering experience that it's really difficult. We conclude that we have two cycles, the machine learning life cycle and the actuarial control cycle, but they have the same goal. And there are machine learning operations principles that can enhance the way we think about actuarial models in general, not necessarily only machine learning use cases inside actuarial models. It's just actuarial models in general can actually, our practices can be enhanced by some of these MLOPS principles. All right, so I'm going to tell a story. So once upon a time, a long, long time ago, there was a data scientist. Okay, this data scientist, let's say his name is Steve. Okay. It may or may not be my alter ego. So Steve was given a task. He started working as a junior at a bank. He just came relatively fresh out of university. He's got a good coding experience. He's got good modeling, stats experience. He's recruited as a data scientist, okay, and he's given a task, build a fraud model for transactions at this bank. So very simple, really. A transaction happens. We need to know if it's fraud or not. And Steve went out and he built the most amazing model. He collected data, like a lot of transactions data, a lot of different statements from different people, extracted the data, and he trained this amazing model. And he focused so much on this model, okay? His entire focus was he's going to build the best predictive model out there, okay? And what he did was he would take the context of the most recent transactions in the model, like maybe the last 1,000 transactions of every person. He would take that into context, into consideration when he would like make the next prediction of the next transactions to see if it's out of place, you know. So he'd look at the different characteristics and so on, and it was performing really well. Like when he does when he tests it on out of sample data, it performs amazing. This model is great. It's going to be a massive success. He's going to get, he knows he's going to get promoted when this thing gets out there. He's going to be so popular. He finally goes to the IT department and say, "Here's the model," and they tell him, "We don't have the historic transactions data available when transactions happen. Why? Like, is it not obvious? Like, it's not viable to give this to you." Okay, so he goes back to square one, builds a new model. Okay, and over time he realizes that the model is actually a really small part of the wider process supporting the modeling environment. So this is not us making the story up. This is from a paper introduced in 2015 from researchers at Google. This called, like some people call this paper the black box paper. It means like the black box is really small in the bigger context. So data collection, data verification, machine learning, resource management, the supporting infrastructure, everything is so much more important than the model itself. Another example is he went out and he trained a new kind of model, and it was maybe like a deep learning use case. When he went out to the infrastructure guys, they told him, "It's too expensive to train this model. We can't continually retrain this thing every week. We don't have this supporting infrastructure." So but then Steve had to learn to actually work with GPUs himself to help those infrastructure guys at the bank to see find a cheaper way of actually training this thing. So machine learning engineering is a field where you touch. You're a software developer and a statistician and a modeling expert, and you're a developer and you know infrastructure really well. So it's a really wide, difficult field. So this is the introduction to machine learning operations. Okay, but what happened is Steve realized that the challenges that he's facing is actually really, really similar to the same challenges faced in software engineering, classic software engineering. And what did software engineering do to solve these problems? They developed the DevOps principles. So just to conclude, the infrastructure supporting the model is more important than the model itself. When you define initially the goal of the project, you need to take this into consideration. We know that the surrounding infrastructure should not be underestimated. And MLOPS actually comes from learnings from DevOps. Okay, so if you want to apply these principles as well, you should look at try and learn DevOps, I would say, as our first principles. So that is principles like test-driven development, automated model evaluation, so testing whether your model is working well. It's continuous delivery, so continuously making improvement, building a system which optimizes for continuous improvement. So all these principles align with DevOps principles, and that's basically the essence of machine learning operations. All right. So now to introduce the machine learning life cycle. Okay, so this is really interesting because it's actually if you were to draw it up in a different way, it's very much like the actuarial control cycle, but it's got like one or two key differences. Okay, so it also starts with an iterative, it's also an iterative model. So at any point in time, you can jump back to a previous stage. It's meant to iterate, and you're meant to learn. Like you experience something, and you learn, and you go back and you revisit. Okay, so it also starts with problem definition. And then it goes to a bit more of an opinionated approach of how you collect data than the actuarial control cycle. And then the modeling happens. So this is where you develop, you train the model, and you test the model. And then finally, you deploy the model. And after deploying, you build a system which can monitor this model. Okay, so really, it's quite simple. Looks quite linear, but at any point in time, think of it as like iterative and circular as well. Okay, so just a quick recap of the actuarial control cycle. So for those of you, just a refresher, or you might not have studied it. So it starts with defining the problem, developing the solution, monitoring the results. So I know some of you might know it doesn't monitoring the experience, which is also applicable. But so this is the official one. It's actually monitored the modeling results. Okay. So also I think that the key difference here is that everything is in the context of professionalism. We were meant to apply our professional judgment in when we define these solutions, and I think that's what makes actuaries special. And we there's a reminder to always take the external factors into account. Okay, now I don't think that's I think that's just wisdom. All right, so. But I think the core essence of it, and I guess the way it was taught to me, is that it's a problem-solving framework. And that's what the machine learning lifecycle also is. All right, so now I'm going to hand over to Neil.
Thank you, Stefan. Okay, so Stefan introduced that quite nicely. We're going to look now at a case study to compare the two frameworks to see how we can avoid falling into the same trap as Steve did. So let's go. So let's say we've got two people. We'll call them person A and person M for no particular reason. Person A will follow the ACC and person M will follow the MLL. We're setting out to solve the same pricing challenge. We want to build a real-time pricing engine that can deliver X amount of quotes in a specific amount of time. So when we define the problem under the ACC, the main purpose is strategic clarity. So this is where we will bring in a lot of domain knowledge and understanding of the problem and what do we want to solve. Whereas under the MLL, there will be much less of domain knowledge applied to the solution, but we will consider production readiness and integration. So this speaks quite closely to what Stefan said about avoiding the trap of building in a parameter like historic data that's not available. So we'll pick that up here. Collecting data under the ACC is more periodic. It's manual extraction in many times, where under the MLL, it is continuous and will focus on automated pipelines. So I do think that here there's a very strong focus on data engineering, as Stefan mentioned as well. So the MLL person will put a lot of focus on how they bring their data in. They might spend a lot more time here than the person building on the ACC, but that will provide some optimizations going forward. Processing the data under the ACC, it's semi-automated. We'll generally work with static data sets. Under the MLL, we'll use our integrated pipelines and orchestration that was built during more under data engineering principles. Feature engineering, or the EDA, under the ACC, it's a manual process. We use inference and interpretation there. Under the MLL, it's once again, we'll use pipelines. There's a feature store. And here we'll also consider how we're going to monitor our model. So this is something we'll speak quite a bit about, and this is the one area where we think there's a lot of room for improvement when we consider deployment. So when we deploy the model, we will already be thinking of how we're going to monitor this model in production. Selecting a model, the ACC will select something that's interpretable, and this is once again driven by governance mostly, and we want to understand what we're doing. We don't want any black box models. The MLL will focus purely on performance. What model is most predictive? How accurate is it? Training the model. So here we'll do, under the ACC, it will be parameter estimation. It's linear, step by step, and there can be overrides. Once again, there's a lot of domain knowledge in the ACC. So if we feel something doesn't look right, there can be a manual override, whereas in the MLL, that will not happen. We can have automated retraining, and we're going to optimize for performance. Evaluating the model. ACC, once again, periodic. It's static evaluations. We focus on compliance. The MLL is continuous. It is automated. We can have fairness audits, and we focus a lot on cross-validation to evaluate whether our model performs well or not. Deployment, very, very important step here, and I think this is probably will become a bit more clearer in the next slide. But this is probably where the biggest deviation is between the ACC and the MLL. Under the ACC, we would have fitted parameters. We hand it off to IT, like Steve did, and then we'll have periodic reviews. This could be quarterly, annually, whatever the case might be. Under the MLL, you'll generally find that we've been working in a development environment. We might have a UAT environment where we test the model, and only once it passes those tests, we'll push that into the live production environment. We do this by using CI/CD pipelines. We can have different deployment strategies, and also this is where we will monitor our version control, which is actually very good for governance. Monitoring and maintain, so this is very similar between the MLL and the ACC. Biggest difference here is the ACC will be periodic again. It's mostly for regulatory review. We'll look at static data trends, whereas in the MLL, this can happen daily if the model and the pipelines are set up correctly. It's real time, it's automated, and here we will look at some of the parameters that we defined earlier to pick up drift, context drift, data drift. It can also be used as compliance. So the ACC meets the MLL. So we've seen that it's two different frameworks, but it has one goal ultimately. So it's iterative. We use it to solve problems. The biggest difference that we identified is the deployment. The MLL has an explicit deployment step, whereas under the ACC it might be a bit more implicit. We've got automated monitoring under the MLL, and the MLL has quite a big focus on infrastructure considerations early on, and with the MLL we've got near real-time feedback, and that is probably what drives the infrastructure challenges. I'm not going to go through that again. So what is the missing link? So we think, or we concluded through our paper that it is deployment. So why does deployment matter? Deployment makes you consider data engineering quite heavily. If you want to monitor your model in real time, you have to get your data engineering right. If you want to make quick updates, you have to get your data engineering right. There's also the deployment phase helps us a lot with governance. Reason for this is we'll generally have three environments. We'll have a development, UAT, and production. And everything, there can be very strict rules before we move models through environments. Deployment also helps us with continuous monitoring. This once again can help us to pick up concept drift, data drift, anything like that which can trigger something previously in the step. We can retrain our model and it goes through all the steps again. So this is how we see the ACC could be reimagined by including an explicit deployment step. What this will do is it will help us consider deployment in the problem definition, as well as look at a lot of the monitoring implications to make it more real-time and more instantaneous. So what did we see? So we know that ML is augmenting traditional actuarial methods. We know there's challenges integrating ML models into our operations. The ACC and the ML are two cycles, but it's got one goal at the end of the day. MLOPS, the principles of MLOPS can enhance the ACC. Who's got the first question? Here we go.
There is a roving mic. Can we get it?
Hi, Andre from Life Healthcare. So, one of the purposes of DevOps being developed along with Agile was how do we collaborate better on very complex technical problems and, be responsive to the business needs in what we deliver. So my question is, in the context of A, working in teams on building these models, and B, transferring legacy models into an MLOps environment, if you have any thoughts on those aspects.
Okay, so maybe on the first question, I do think it's challenging because it's such a vast environment, and particularly if you bring in an actuary skill into that, I do think that it will always remain different. How can I say it will be different departments, but what we are or what we are considering here is that they actually should consider during when they build the model, consider all these steps so that it can be handed off to let's just call it the MLOps department to deploy. So that is on the first question. So that's how, I don't know if I speak for Stefan as well, but that is how I see that happening. And on legacy, so legacy is always going to be challenging to get everything over. And I'm not sure when you say legacy, are we talking on-premise servers opposed to cloud, or are we saying your old models that you want to... Old models. So there, it's probably going to be a stepwise approach, prioritize, and get them over one for one.
So I just want to respond to a question as well. So I totally agree. One of the aims of DevOps is to optimize for learning. Okay, so work in small steps. and because it's really good for very complex projects where you cannot plan. You do not have the mental capability of planning everything in advance. You need to take it step by step. I'm actually busy with a project like that right now, where there's a legacy system on mainframe running in COBOL on premise, and we are helping to rebuild it in this environment. I think one of the key things is I think it is very valuable for the actuary to own deployment. Find a way in which the actuary can own and govern their own model instead of handing it off to a different department. So make it part of the actuarial department's role. I think that's one of the key things, as opposed to like getting the legacy systems over into this environment. My opinion is start with a replication process and really apply test-driven development. So take test cases from the old system, input case and an expected output, and automate tests. So there's confidence that the new system replicates, and then you do a switch over, and then you can start adapting the new system, because the new system allows for change. So that's how we're approaching it. I think there are other ways as well, like just rebuild, for example, rebuild the new system like you want it, and take a certain day in the future where you aim to just switch over, but then your modeling approach might change all of a sudden or something. So there might be like a business disruption sort of effect there. But I think that one would most likely be faster.
There was another one in that row, and then one at the back and one in front. We only have 3 minutes, so please keep it short.
I'm Willem Dirk from First Rand. My question touches on the previous one in terms of an MLOPS. Do you believe there should be a specific MLOPS department, or should it sit somewhere else within infrastructure? And related to it, how do you kind of or have you seen and have you dealt with pushback from the way we've been doing it works fine? Why do we need MLOps?
Okay, so on your first question, I do think that it sits separately from the modeling team, but it can sit very quickly to your infrastructure teams, dependent on what your infrastructure team looks like and what the skill set is within that team. But I've also seen you having guys within DevOps that specifies or that specifically works on MLOps. But I definitely believe that they sit in the infrastructure team, because a lot of the things that need to happen for successful deployments will be in your infrastructure. So that's on the first question. And sorry, the second one, can you please repeat?
Basically, when the people in infrastructure or elsewhere in the business says, but everything's working fine, why do we need MLOps?
Okay, I'm going to pass this one to Stefan.
I've seen that before, yes, definitely. It's I don't know. Like to convince someone, and I've experienced this as well. Like trying to convince like my managers as well. Like it's been a real challenge. You need to prove it, sort of. Or I found it really useful to give them statistics, like quote from the book called. I'll remember the name later. But there's really cool case studies with like Tesla, Yeah, so I think Tesla is one of the companies that has really the coolest findings for automation and why they're ahead of other automotive guys. But it really comes down to an engineering mindset versus a traditional actuarial mindset. And I think it's difficult because you're not on the same page to start with. So, yeah.
Sorry, guys. I hope that answers many of the questions that were there. Your transition time to the next session is 15 minutes. There's been a couple of schedule changes. Firstly, actually, thank you guys very much. I actually had more questions about just like drift alerts and that sort of thing, because now you're going to have actuaries that are just drowning in like false alarms and stuff. But we'll talk about that afterwards. And then, yeah, so your refreshment break at 9:15 is until 10:20, because the presidential plenary is 10:20 to 11:45, and then your lunch break will be from 11:45 to 1:10. So yeah, thanks a lot, guys, and thank you for pitching up for this one. Cool.
We're around for questions if you want to hang around for 5 minutes.
Cool, thanks everyone.